Hey everybody, welcome to Unit 8, Counting and Probability. A lot of real-life situations in this, pretty applicable to pretty much any situation you can think of. So let's start right off with factorials. Factorials are a pretty interesting thing. You'll see once we get into it, a lot of students I've had in the past found this to actually be, I don't know, a little bit fun. There's a lot of crossing stuff off, so you'll see. But anyways, a factorial. Factorial is the product of n and all the positive integers before n. And you're going to see right here, the way that we write it out, it's n with a little exclamation mark, right? So when you see that, that's a new symbol for you. That means that you're multiplying every number up to n. So for example, if n was 6, we'd be multiplying 1 times 2 times 3 times 4 times 5 times 6. Okay? But there's one thing down here that we're going to make a note of, and it's that 0 factorial is not 0, but in fact it's 1. And this has to do with something called set theory, and it allows us to do a lot of work with this. If we had 0 factorial equal to 0, we couldn't do any kind of division. Plus, it has to do with the fact that even an empty set, or something with a set with nothing in it, is still considered to be a set. So that's why they say that 0 factorial is equal to 1. So anyways, we're going to do a couple of problems with this factorial just to get used to it. Alright, so 5 factorial, you're doing 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1 is 120. Now I did that the long way on the calculator. I will show you in a second how you can do the shortcut with the actual exclamation mark. But you're going to try out 11 factorial. So if you want to pause the video and resume when you're ready to check it. Alright, let's check it out. You're doing 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. Right? So if you either typed in all that into your calculator, or if you did it out by hand, I guess you should have gotten some sort of number. I'm going to show you an easier way to do it than doing 11 times everything on the calculator. I'm going to show you how to do the shortcut. So this is what you're going to do. Okay, here's our calculator. Turn it on. Let's see if we can put it over here. We can see it better. So you're going to type in your number first. So we're doing 11. Then you're going to press math, which is right underneath the alpha key. And you'll go over to PRB, which stands for probability, and option 4, which you don't have to scroll to. You can actually click the number 4, but option 4 is the factorial. So now we have 11 factorial. You click enter, and whoa, that's the number we get. 3991680. Okay, so pretty easy to do, and we're gonna do some stuff with them that's kind of fun stuff, I guess, if you're interested in this type of stuff. Anyways, so factorials follow the usual order of operations, right? If we have 3n factorial, that really means that we're doing 3 times n factorial. In other words, we're doing 3 times 1 times 2 times 3 all the way up to n. Okay, that's a little bit different than if we were doing 3n all factorial. That would mean that we're going all the way up to n and then past it all the way up to 3n, right? So depending on how these things are written, your calculator will give you different numbers. So just be careful with that. But that being said, because we're able to do different order of operations, we can start applying them in terms of like sequences and series, right? So we can write the first 5 terms of this particular sequence if we just plug in 0 first and then 1 then 2. That's what we're going to do. We're going to check this one out. So first, we're going to do 2 to the power of 0 minus 2 over 0 factorial. Anything to the power of 0 is 1. 1 minus 2 is negative 1. And then 0 factorial, we said earlier, was 1. So we get negative 1 for our first term. So we're going to do that for 4 more terms, but this time we're going to do n as 1. So now we have 2 to the power of 1, which is 2. Minus 2 is 0 over 1 factorial, which is 1. 0 over 1 is 0. Now we're going to do it with our third. So let's see. The next number in line would be n to 2. So we have 2 squared, which is 4. Minus 2 is 2. 2 times 1 would be 2. 2 over 2 is 1. Alright, so I'm just plugging in everything so far. This is where it's going to get a little bit more interesting. When we do n as 3. 2 to the third is 8. 8 minus 2 is 6. But then here we have 3 times 2 times 1. Right? That's 3 factorial. 3 times 2 is 6. So that's going to cancel out. And it's going to give us 1 again. And we've got one more to look at, which will be n equaling 4, because that'll be our fifth term. So 2 to the 4th minus 2 over 4 factorial. Let's see, 16 minus 2 is 14, and this is over 4 times 3 times 2 times 1. So let's see if I divide here and here, that becomes 7. So let's see, 7 over 12. That's a pretty interesting series, or sequence rather, of numbers, right? This is what we plugged in, and we just plugged in 0, then 1, then 2, then 3, then 4. We're going to end up with negative 1, 0, 1, 1 again, and then all of a sudden 7 over 12. Very interesting how these things come out. It also makes it incredibly difficult for you to guess the answers for these, because we're about to do another one right here. And you'll see that you're going to get completely different answers. Anyways, so this one just says 24 divided by n factorial. We're going to start with n equaling 0. So if we do 24 divided by 0 factorial, that'll give us 24 over 1, which is 24. 24 over 1 factorial. Oh, that's just 24 over 1, which again, 24. 24 over 2 factorial. Now we're starting to get a little bit of change going on here, because that's 2 times 1. Now we can start reducing. That's going to give us 12. 24 over 3 factorial. Alright, so 24 hasn't changed. We're going to break this apart to 3 times 2 times 1. So now we can start dividing, right? I know that 2 goes into 24 12 times, and now I can divide this even further. 3 goes into 12 4 times. And we've got one more to do. We've got 24 divided by 4 factorial. 24 divided by 4, 3, 2 times 1. So let's see. 24 divided by 4 is 6. 3 goes into 6 2 times. 2 goes into 2 1 time. And we get 1. Very, very crazy solutions here, right? 24, 24, 12, 4, and 1. So not very easy to just guess. It's not also something that you can just very easily, look at and get the answer right in your head just by looking at it. There's a little bit of work to do. So you've got one right here that you're going to try out. Pause the video and resume when you're ready to check. Alright, let's see. So remember, you're plugging in 0 first wherever you see n. So you got 0 factorial over 0 plus 1. 0 factorial is 1. 0 plus 1 is 1. First term, 1.
1 factorial over 1 plus 1. So that's 1 over 2.
That one needs no reducing.
2 factorial over 2 plus 1. So that's 2 times 1 over 3, which is 2 over 3. 3 factorial over 3 plus 1. 3 times 2 times 1 over 4. We can reduce a little bit here. The 2 and the 4 will reduce. So now we get 3 over 2. And finally, 4 factorial over 4 plus 1. 4 times 3 times 2 times 1 over 5. Let's see. That's 6 times 4 is 24 over 5. So here is our final answer. The first 5 terms would be 1, 1/2, 2/3, 3/2, and 24 over 5.
So factorials are actually kind of easy, interesting. They give you different solutions. Pretty fun. This is a little more fun, I think, people have with factorials would be the crossing stuff off, right? We're going to be simplifying factorials. So what we're going to do here is we're going to start expanding, and once we expand enough, you're going to notice that we can cross off groups of stuff. So this weird looking fraction right here is going to hopefully reduce down to a nice even number for us. That's the hopes anyways. So let's see, let me get a pen going here. So here's what we're going to do. We're going to expand this. All right, this would be 7 times 6 times 5, 4, 3, 2, 1, all over, and I'm going to just expand these as well. 3, 2, 1. They're multiplying here, so times 4, 3, 2, 1. Now, this is where I was saying it's kind of fun because stuff is going to cross off really nicely for us. Notice how we have down here 4, 3, 2, 1, and it matches with 4, 3, 2, 1. So we can actually just go like this and cross all of those out all at once. Be careful, we did not cross off the 5. We crossed off the 4 down to the 1. But we also have some other stuff that we'll be able to get rid of too. Like, for example, 3 times 2 is 6. So I can get rid of the 3, 2, 1 and the 6. By the way, the 1 really doesn't matter in this situation because anything times 1 or divided by 1, it's not going to change. So the 1s are basically useless. But we got rid of everything from the bottom, right? Denominator's clear. We're left with 7 times 5, which is 35. Pretty fun, pretty easy to do. So you're going to try this one out. Pause the video and resume when you're ready to check. Alright, let's check out this solution here. So you expand 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You're going to expand these as well. 4, 3, 2, 1 times 8, 7, 6, 5, 4, 3, 2, 1. Now these line up nicely for us. All the way from 8 to 1, those all will match. They'll all go away. 4 times 3 is 12, so I can get rid of that. And 2 times 5, so I can reduce the 2 and the 10. So what we have left over is 11 times 5 times 9. 495. Hopefully you got that. When I've done these in the past, students who usually don't even like math for the most part, they're like, hey, this isn't bad. You know, it's just crossing stuff off. Those problems definitely fun. Then we can get into some more that are a little bit more thought-provoking. So I'm going to take a little bit of time to explain what's going on with these. A lot of it's the same, right? We're going to expand just like usual, but it's these ends that are in here that are going to be a little weird, right? So let's just focus on expanding the 5 first. 5, 4, 3, 2, 1. That's still multiplying here, but I'm not quite sure what this thing looks like, right? N plus 2. So let's think about it. Before the number n plus 2 would have to be n plus 1. And before n plus 1 would have to be n plus 0, or just plain old n. Right? And before that, we could even do more. We could do n minus 1 and n minus 2. So we can actually expand this quite far if we needed to. I don't know exactly how far I need to go, so why don't we do something like n minus 1. Now, I'm including everything before n minus 1 and n plus 1, and then all the way up to n plus 2, which is what this n factorial told me to do. So when you see something like this, basically you're just going to write maybe a couple of terms. I don't know exactly how many we needed yet, but we'll write a few terms. If we need to shorten it up later, we will. But hopefully something in the denominator will start to cancel some stuff out for us. So now we start to do the bottom. The 3 we're going to expand. 3, 2, 1, and then we're going to do the same kind of thing with this n, right? What comes before n would be maybe n minus 1, for example. So we're multiplying, and I'm going to just go right from here. N minus 1 times n. So we went all the way up to n. So I want you to notice from here to here, including these little dots, which you can't really see very clearly right here, but that all matches all of this stuff, right? We're taking away from n and anything before it, including whatever happens to be coming before n. Right? I don't know what it is. It could be any numbers, but we're getting rid of all of them from both top and bottom. So now we're left with solid, I guess you could call them numbers, right? We would have to plug in the value here, but these things are concrete. Whatever we happen to put in here. This is going on infinitely. We don't know where it goes, right? So that kind of took care of some of those abstract pieces for us. We also have the 3, the 2, and the 1 that we can cancel from here. So here's what we have left. 5 times 4, which is 20, times n plus 1 times n plus 2. Basically saying you could plug in a value for n here and do all this math, or you plug in the same value of n here and get it much quicker. So I'm going to do one more with you before I let you try these out on your own. Okay, looking at this one, n plus 2. If you think about it, what are the numbers that come before 2? 1, 0, and we could even include negative values like -1 and -2. So I'm going to go, I'm not quite sure how far back. It looks like I'm going to have to go back maybe to -2 or so, because I see a -1 down here. So I'm just going to expand this. So dot, 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 n minus 2, n minus 1, n plus 1, n plus 2, and that's where we're going to stop because we're going all the way up to n plus 2. So we're including everything before it. Let's expand this. This thing's not going past n, right? It's at n minus 1. So the things that come before it would be numbers like n minus 2, n minus 3, minus 4, right? Those all are within those little dots right here. Right, so what we have right now is the expanded form of this. But we can get rid of some stuff, right? From here to here, this all matches, including those little dots telling us to go on forever and ever and ever. So we can get rid of all that information, and our final solution is going to be n times n plus 1 times n plus 2. Cool. All right, so you got a couple to try down here. If you want to pause the video and resume when you're ready to check both. All right, let's check these ones out, the more abstract ones. Right, so we're going to expand
6, 5, 4, 3, 2, 1. I'm going to have to go probably to like n minus 2, somewhere around there. So times dot 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 n minus 2, n minus 1, n up to n plus 1. So that's where we stopped. This 2. We expand to 2 times 1. Here we're going to do all the things up to n minus 2, n minus 1. And that's where we're going to stop. So let's see. 2, 1, 2, 1. Those all go away. These right here all cancel. These will all cancel. So let's see. 6 times 5 is 30. Times 4 is 120. Times 3 would be 360. And then we got n times n plus 1.
Sounds pretty good.
Your second problem. Ooh, this one's a tough one, right? I don't really know what comes before all of this, so I'm going to expand this to n minus 2, n minus 1, n. So that's where that one ends. This one we're going to go dot 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 n minus 2, n minus 1, n plus 1. And this one will go n minus 2, n minus 1 is where this stops. So this is not looking like it's going to be a very friendly looking solution. It's going to have some dots involved, but whatever. So what we're going to do is we're going to get rid of from here to here. This all matches. That's all gone. Well, it looks like we're multiplying n times all this stuff that comes before it. So which I think we could probably change back to something like n times n plus 1 factorial.
I'll have to look a little more into that solution, but for right now I'm going to say that that's pretty good, especially because we're 23 minutes into this video and I don't really feel like remaking it just for that one little piece. This is really only Algebra 2, so I guess if you're super interested in that, we can look into it even more, but that looks like a solution that I would be satisfied with for right now. So, we'll see you in the next lesson. See you then.